Hello everyone, welcome to my channel Study Junction, and in today's video we are going to solve examples, that is numericals from Force and Laws of Motion chapter of class 9. So let's get started. So this is the example 9.1, first example from this chapter, and it says that a constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. Now if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? So first of all, it is given to us that object's mass is 5 kg and its for a duration of, that is time is 2 seconds, and then we are given the initial velocity and we are also given the final velocity, that is 7 meter per second. And now we have to find the magnitude of the applied force, that is we have to find the force. Now for force we know the formula, that force is mass final velocity minus initial velocity upon time. Now we'll substitute the values. So force we have to find, mass is given to us, that is 5, and this final is 7 and initial is 3, upon time is 2 seconds. So 5 into 7 minus 3 is 4 by 2, and it is 10 Newton. So force, don't forget to put the unit, that is Newton. Now we are set, find the force applied for a duration of 5 seconds. Now the duration of the we have to find the final velocity if time is 5 seconds and force is 10 Newton only. Now again we put all the values in this formula. Now force we know is 10 Newton and mass is 5 kg. This V we have to find and U is 3, and time we know, time is 5 seconds. So this cuts, it will be 10, this implies that 10 is equal to V minus 3. So from here V is equal to 13 meter per second, and hence we have solved example 1. Now let's move on to the example 2, which would require a greater force accelerating a 2 kg mass at 5 meter per second or a 4 kg mass at 2 meter per second. Let's solve. Now we know that force is equal to mass into acceleration, and we are given two cases and we have to find in which case the force is greater. It is case 1 and it is case 2. So in case 1, accelerating a 2 kg mass, it means mass is 2 kg and then at 5 meter per second. So acceleration is 5 meter per second square, right? And here mass is 4 kg and the acceleration is 2 meter per second square. So force is mass into acceleration. Now here we'll find the force, mass into acceleration. It is 2 into 5, that is 10 Newton. The unit is Newton. And here force is again mass into acceleration. Mass is 4 and acceleration is 8 Newton. So we can directly say that case 1 has a greater force. So case 1 would require a greater force. That is a body moving with a body of 2 kg mass moving with acceleration of 5 meters per second would require a greater force. Now moving on to the third example, which is a motor car is moving with a velocity of 108 km per hour and it takes 4 seconds to stop after the brakes are applied. Calculate the force exerted by the brakes on the motor car if its mass along with the passengers is 1000 kg. So first of all, what here is given to us is that it's moving with the velocity. So its initial velocity is 108 kilometer per hour, and we convert it into meter per second, which will be 108 into 1000 upon 60 into 60. So the right answer after calculating this all will be 30 meter per second. Now, after that, it takes 4 seconds to stop, and thus its final velocity will be 0 meter per second. After that, we are given that mass along with the passengers is 1000 kg. So mass is 1000 kg, and what we have to find? We have to find the force exerted by the brakes on the motor car. So we know that force is equal to m, v minus u upon v. That we can say its acceleration. So it will be mass is 1000 kg, and final is 0, and initial is 30, one time is 4, so it will be 1000 into minus 30 upon 4. So after the whole calculation, it will be minus 7500 Newton. So don't forget to put the unit. I am repeating it again. Unit is very important. So it's minus 7500 Newton. It's the answer for example number 3. Now let's come to example 9.4, which is a force of 5 Newton gives a mass m1, an acceleration of 10 meter per second, and a mass m2, an acceleration of 20 meter per second square. What acceleration would it give if both the masses were tied together? So here, first thing we are given is that force is 5 Newton. And in first case, there are two cases. In both cases, force is same. And in first case, we are given mass is m1. Mass is m1, and then we are given that acceleration is 10 meter per second square. So let's say it's a1. Acceleration is 10 meter per second square. And in second case, mass is m2, and acceleration 2 is 20 meter per second square. Now, in first case, we will find the mass first, and in this case also. Now the question says कि अगर दोनों masses को tie कर दिया जाए तब कितनी acceleration होगी, मतलब अगर दोनों masses को combine कर दिया जाए, force same ही रहे तो acceleration कितनी होगी. So first of all, we need to find mass here. We know that force is mass into acceleration. From here, mass will be force upon acceleration. So force here is 5 and acceleration is 10. So it will be equal to 0.5 kg. 0.5 kg the mass is in first case, and now here mass will again be force upon acceleration. So 5 upon 20, and it's equal to 0.25 kg. Now if we add both the masses, m1 plus m2 will be equal to mass 1 is 0.5 and mass 2 is 0.25. So it will be equal to 0.75 kg. Now we have to find the acceleration if both the masses are added. So we know that mass 1 plus mass 2 is 0.75 kg and force is 5 Newton. Now we need to find acceleration. Acceleration will be force upon mass. Force is 5 and acceleration mass is 0.75. So after the calculation, it would be 6.67 meter per second square. So this is the solution for example number 3. Example 4. So in example 9.5, the velocity time graph of a ball of mass 20 gram moving along a straight line on a long table is given in figure 9.9. So as you can see here, how much force does the table exert on the ball to bring it to rest? It means we have to find the force in which the initial velocity is 0. Sorry, the final velocity is 0. So here from the table we can see that its velocity, so the initial velocity is 20 centimeter per second. The mass here given is 20 gram, and then the time taken for this is 10 seconds. So as you can see here in the solution, we can find acceleration from here. So acceleration is v minus u upon t. So here directly we can find it. After that, the force exerted we have to find. So force is mass into acceleration. So we are given the mass also and acceleration we have found. So directly by calculation we can do this, and it's very important to write this. The negative sign implies that the frictional force exerted by the table is opposite to the direction of motion of the ball. So let's move to the next example. Now this is example 9.6. A bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? Now for this question, according to the law of conservation of motion, we know that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now here m1, mass of the bullet is 20 gram. So we convert it in kg. It will be equal to 0.02 kg. And u1. So u1 is 150 meter per second. And here m2 is the v1. See, initial velocity will be 0. So v1 final velocity is this, and initial velocity of both pistol and the bullet will be 0. And now mass of the pistol is 2 kg, and v1 we have to find, u1 is 0. So according to the law of conservation of motion, we know this. Now putting the values, m1 is 20 gram into u1. So u1 is 0 plus m2 is 2 into into u2. So u2 is also 0 is equal to mass 1, that is 20, into v1, that is 150, plus m2 is 2 into v2. We have to find. So it will be 0 will be equal to 3000 plus 2v2. Now minus 3000 will be equal to v2, and v2 will be equal to minus 1500 meter per second. This is the solution. Here I did a mistake. I didn't put the value 0.02. So now this will be equal to, final value will be equal to 3 plus 2v2. And now v2 will be equal to minus 3 will be minus 3 is equal to twice v2. v2 will be minus 3 by 2, and it will be equal to minus 1.5 meter per second. So yes, this is the final velocity of the crystal. Now example 9.7 says that a girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart with frictionless wheels. The mass of the cart is 3 kg. What is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. Now again we will use the law of conservation of momentum here. So m1, mass 1 is 40 kg, and v1 it should be u1, it should be v1. u2, yeah, u. So u1 is 5 meter per second and u2 is 0 and m2 is 3 kg. v1 is we need to find and v2 is 0. So now putting the values, m1 40 into u1 5 plus m2 is 3 into u2. So u2 is 0, m1 is 40 into v1 we need to find plus m2 is 3 into this v2 is 0. Now see here in the question we need to find v1 plus v2 both. So we'll take v only and hence we can put the value 40 into v1. So we will take v directly plus, so m2 is 3 into this v only. Now this will be common, so 40 plus 3 into v. Here it will be 200 plus 0, so 200 and 200 is equal to 43v and v will be equal to 4.65 meter per second. So this is the solution for example 9.7. Now this is the last example 9.8. Two hockey players of opposite teams while trying to hit a hockey ball on the ground collide and immediately become entangled. One has a mass of 60 kg and was moving with a velocity of 5 meter per second while the other has a mass of 55 kg and was moving faster with a velocity of 6 meter per second towards the first player. In which direction and with what velocity will they move after they become entangled? Assume that the frictional force acting between the feet of the two players and the ground is negligible. Now again we will use the law of conservation of momentum here. So mass 1 is 60 kg and u1 is 5 meter per second, then m2 is 55 and u2 is minus 6 meter per second. It is minus because the first player is moving towards, second player is moving towards the first player. Now, next we'll find the v1 and v2, that is v. So, putting the values 60 into u1 5 plus mass is 55 into u2, that is minus 6, and then mass 1 is 60 into v, will take them v only, and then mass 2 is 55 into v only, and it will be 60 plus 55 v, and this needs calculation. Now minus 30 after calculation will be equal to 115 v. V will be minus 30 upon 115, and this will be calculated to minus 0.26 meter per second, and hence this is the solution for this example. So thank you for watching my video, and do watch the next videos for some more examples. I also make the solutions of NCERT and R.D. Sharma, and these are the solutions of physics. I've also tried making one video for Hindi chapters, and some other videos are also there, so you can check out my channel for those things. Thank you for watching this video. Please like my video and subscribe to my channel for more such videos.